This is the first of a couple of videos that I'm going to explain how sort of text files and image files are stored, and we're going to have a look at a close up look at the hexadecimal and the binary of each of those. Now, this is not possible on Windows 10 unless you download a particular piece of software. I'm on a Mac, as you can see, but I've got a couple of virtual machines. Now, much of what I'm saying is what you need to have an understanding of for the course and for the exam. So this is a Mac, and I'm going to go to a virtual machine, and this virtual machine is Windows Server 2003. And we're going to look at a file, and we're going to create a text file and an image file later in here, and we're also going to do the same thing in Windows 7. I don't have Windows 10 at the moment, so if you've got it at home, then you will need this program, Hex Editor Neo, downloaded to your computer. But I've got to warn you, it is quite dangerous when you're looking at files, because you can actually change things that you maybe have paid for, and you will break them. So please be careful. But first, I'm going to start off with the Server 2003, and I'm going to create a very simple text file. I'm going to use Notepad, and I'm just going to type hello world. Now, we've just looked at text files, and well, not necessarily text files, but we've looked at character sets, and we are using here a straightforward ASCII character set. So what that means is that for every letter, H, E, L, L, O, it will take 1 byte to store it. So if you take a look here, I've got 1, 2, 3, 4, 5, a space making 6, 7, 8, 9, 10, 11 characters, which is going to be 11 bytes. So if I do this, file, save as, and then on my desktop, call it hello. And notice here we've got what we call encoding. It says ANSI, which is the same as ASCII. We could change it into Unicode, UTF-8, or Unicode Big Endian. That sounds good. But we're going to stick with ANSI, which is roughly what you looked at before, with 8 bits representing 1 character. So I'm going to save that, and it pops up on my desktop. Now, the reason I've done that is so that I can run a program that you cannot run these days on your computer, and it's the command prompt. This is called a graphical user interface because we can pick things up, we can drag them around, and it's pictures. But the command prompt is a little bit different. We can only use the keyboard, and we can only type letters. And you need to know a lot of commands to make this work. So for example, my hello.txt is on my desktop. So I'm going to have to find that desktop. I'm going to start off by typing dir to give me the listing of my directory, all the folders I've got here. So when I press enter, it tells me I've got favorites, my document, start menu, a trace log, and there is my desktop. I can't click on it. It's not going to do anything. I can't drag it around. I can drag the window, but I can't do anything with the text. So this is purely writing commands. Again, something very useful for your course and the exam. And I'll go through these files a bit later on when we deal with it more specifically. So I'm going to change, I want to go into my desktop so I can access this file. So I type cd for change directory, and then desktop. Now, it doesn't need to match the case, that's fine. If you were in Linux or Mac, then you would need to think about the case. We're not, so we don't bother. Windows is case insensitive. So I press enter, and it tells me here that I am in my, or looking at my desktop, but it's not showing me any of the files. To do that, I need to type dir again to give me a directory listing. When I press enter, there we go, I've got hello.txt, and it tells me that it's 11 bytes long, and we figured that out when we counted the characters. So what I'm going to do now is look inside this file, and to do this I need a program called debug, and then I need to say what the file is, hello.txt. and it just gives me a little line here waiting for me to type something. And you need to know these commands as well. D means dump, so I'm going to dump all of the data from inside the file. And what I want you to notice on the right hand side here, it's got the text hello space world, and that's the end of the file there. This is garbage, doesn't belong to the file, it's just because it's looking at a lot of memory. And if you notice on this side, we've got hexadecimal values 68, 65, 6C, 6C. If you convert those to decimal or take a look at your ASCII table, you'll find that that is HELLO, 20 is a space or 20, then WORLD, and that's the end of my file with AE. And that's my 11 bytes. So that is looking at it with the command prompt. I'm going to do the same trick now with Windows 7, which will not allow me to get the command prompt. I have to use a special piece of software, and that special piece of software is called the Hex Editor Neo. Right, so this is it's a graphical user interface, so I've got my mouse and I can play with everything with my mouse. But first of all, I need to do that hello.txt file, so I'm going to choose the same thing. I'm going to go for Notepad. You could use Notepad++. I'm using Notepad because it's the most basic thing going. So I'm going to type in here hello world. So now I'm doing exactly the same as I did in 2003 on Windows 7. Then I'm going to choose File, Save As. I'm going to find my desktop, and I'm going to call it hello.txt, just as I did before. So close down my Notepad. Again, we know it's 11 bytes because there's 11 characters. So if I choose File and Open, I can go to Open File and go and find my desktop. And hopefully somewhere on my desktop will be a file called hello.txt. And there we go, hello.txt. Notice it's 11 bytes. So each character in a text file is 1 byte. So you can work out the size of your text file by the number of characters that you type. I could also sort of change this to give me details. In other words, I can see more information about the file. So if I just scroll down to hello.txt, notice that this time it doesn't tell me it's 11 bytes, it tells me it's roughly 1 kilobyte. It's sort of not being very accurate, it's just estimating 1 kilobyte. But if I go back to the picture view, large icons or small icons I should have got, then oops, it doesn't tell me that. It should tell me as some part that it's 11 bytes long. There we go, it's the tiles. So where's my hello.txt? There we go, 11 bytes. So that's the one I'm going to choose and open it. And again, we get this version in hexadecimal. Now, when I was dealing with Windows 2003, it gave me all the rest of the information that was sort of either on the disk or in the memory after my file. It didn't sort of just give me the file, it gave me everything in the memory. And all of this is just not used or not there. However, in this one it says, okay, I've reached the end of my file, I'm not going to show you any more information, it's neater. And here we go, we've got the hexadecimal. 68, 65, 66, 6C, 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 that is a space, and then WORLD, and that's it. Now, the reason why I've used this is that I can show you this in binary, so I can actually modify these bits. So I'm clicking on the H. I'm not sure if you can actually click on these. Yes, you can click on those. So I'm clicking on the H, which is 68, and I'm going to choose Modify Bits. And this is now giving me the representation in binary of 68. So 0110 is 6, 1000 is 8. And I can play around with these. Now, again, again, when we were dealing with the ASCII table, I said if you set bit 5 to 1, you got the lowercase. If you set bit 5 to 0, you got the uppercase. So I'm going to click on bit 5 and change it to 0. Okay, so 1, 0. So I've changed that to uppercase H. And I can do the same with world, which I'll do a little bit later. But notice that we've got the binary representation here, split into 2 nibbles. That is now, it was 6, it's now 4, and that remains at 8. And we can see the fact that it's 4, 8 now. Let me take the 0 back and it will be 6, 8. There we go. 4, 8. Remember, octal was another way of looking at information. Excuse me. Decimal was another way of looking at it, converting between the two, but we're using hex. And if I do that, that's fine. When I click OK, that 6, 8 will change to 4, 8, but more importantly, that H will become a capital H. And there we go. And it's in red to say that I've changed it. And I could do the same with the W. I can click on there, I can go to File, Edit, Modify the bits, and change that 5th bit to a 0. Click OK, and I've just made that a capital W. It's changed. If I saved it now, okay, that's it. I've overwritten the file. I've changed the file altogether. And if I go back to Notepad++ and open that file again, so it's on the desktop, it was under Hello Text. There we go. I've got Hello World, capital W, capital H. So I've actually modified my text file using binary, and this is the representation of it. That's why you need to be careful with this, because if you've got a program, you can change the program, and if you don't know what you're doing, which even I wouldn't know what I'm doing half the time, the program will be damaged irreparably. You can't get it back. So that's my introduction to text files. We need to do the same looking at images. We might take a couple of videos to do that.